Hi there. Let's look at graphing inequalities. By now you should know how to just graph lines, and we oftentimes put things in slope intercept form to graph lines, but there are other ways that we can graph them. But now what we're going to do is, instead of having an equation, we're going to have what we call an inequality sign, which is this little less than or greater than symbol that goes in between. Now, I'm still going to try to graph this line, and I'm going to ignore the fact that it's an inequality, and I'm going to pretend that it's an equal sign for right now. I like to graph things using slope intercept form, so that's what I'm going to do here. I'm going to go ahead and put this in slope intercept form. Recall that that's the y equals mx plus b, which means basically we just want to get that y isolated. And I'm going to do several examples. It's kind of the same process on all of them, but I kind of gradually make this equation just a little bit trickier as we go along. To convert this given inequality into slope intercept form, I need to get rid of this 4 that is on the y, so that that y will be sitting there by itself. I'm going to divide everything by 4 to isolate that. That's going to get me a y less than or equal to 2/4 reduces to 1/2 x, and 8 divided by 4 is going to reduce to a 2. Now, what I have created here is a line in slope intercept form that is what we call the boundary line. In the past, what we've been doing with these lines is we've been trying to find the set of ordered pairs, all the points that would make this equation true. And it would just end up being a bunch of ordered pairs that lined up into a linear pattern. Now what we're doing is we're looking for all the ordered pairs that don't necessarily land right on that line, but all the y values will be less than that line. Okay, let's just look at what it's going to look like on a graph, and that will kind of help us. This is what we call the boundary line. I need to graph that first of all. Now, one of the things that's important to recognize is whether or not your inequality has an or equal to symbol. Because what that's going to mean is that all the ordered pairs that actually land on the line are part of the solution set here, because it's a less than or equal to. But if this was not an or equal to, then the actual boundary line, those ordered pairs, wouldn't work. We designate that on a graph by either making it solid or dashed. If you have a less than or equal to or a greater than or equal to, that means that you want to put a solid line, and it's going to include all the points that land on that line. If I just have a less than or I just have a greater than and it's not an or equal to, then I'm going to use a dashed line. And that way it creates the boundary line that I want, but I will know that it doesn't actually include that line. Now, on your software, rather than just using the slope intercept form method to graph, they go ahead and ask you to plot 2 points that would land on that line. They're just trying to help you kind of get the line graphed. What I would do is I would look at this and say, okay, the y-intercept is -2. I know that I'm going to have this point right here. That's my y-intercept. And my slope is 1/2. So that means I'm going to have to rise 1 and run 2. And I'm going to put a dot right there. Now I could sit there and do that over and over. Rise 1, run 2. Rise 1, run 2. And that kind of makes it easier to see that linear pattern. But they really just want me to list 2 points. And I can pick any 2 points as long as they end up working for this line, then it's going to get accepted. I'm going to start off and I'm just going to use this very first one. That ordered pair is 0, -2. That's what I would type in here, 0, -2. And then I have to pick another point, and any of those 4 that I plotted would be fine. I'm going to go ahead and do the next point, which looks like it's over 2 and down 1. So that would be that ordered pair. And I got ahead of myself. I'm sorry. I was sitting here talking about this, but you do have to click one of these options. So if you look here, this is a less than or equal to. So I would click solid because I'm going to want it to be a solid line. These are 2 points that will fall on my line. And after I press enter, it's going to go ahead and graph that line that I want. It's going to be a solid line, and it's going to go through those 2 points that you picked. As soon as you select that and it graphs it, then it's going to come back and it's going to type in, and you'll see there will be like a little A on one side of your line and a little B on the other side of your line. Because right now what I have graphed is a linear equation. This would be great if this happened to be an equal sign. It's not an equal sign. I want all the points that would work such that the y value is less than or equal to where that line falls. That means it's really going to end up being everything on this side of the line, or it's going to be everything on this side of the line. The most accurate way to decide whether I want to shave in the A section or the B section is to do a test point. And so I'm going to pick a point, and I like to use the origin because it's super easy to plug in. I'm always going to pick the origin right here. So that means I have an ordered pair of 0, 0. And if my 0, 0 point, if the 0, 0 works in my equation, then I will know that I want to shade where 0, 0 is. I'm going to come up here, and you can do this on paper. You can just do this in your head if you'd like, but basically what you're doing is you're taking 0, 0 and you're plugging it in for your x and your y, and you're testing to see if it works. So 0 in for x and 0 in for y would look like this. And simplify that up. 0 is less than or equal to 1/2 times 0 is just 0 minus 2. And then you look at this and decide, is that true or not? Is 0 less than or equal to -2? And it's not. What that means then is 0, 0 is not a solution to this inequality. This spot right here didn't work, which means that everything on this side of the line isn't going to work. Because that was one of my, I just have to do one test point and see if it works or not. And if it didn't work, then I'm going to shade on the other side. I want to shade on side B, so it would look like this. And everything in this shaded part, any ordered pair that I pick, that's in this shaded part, where I could pick any one of these ordered pairs, whatever I want, and plug it in up here, and it would work in that inequality. And any point that I would pick over here in this non-shaded would not end up working, like our example here did not end up working. And because our line is a solid line, any point that would land on that line would work. And in fact, what would happen is it would end up, these two numbers would end up being equal to each other, because that's where the line is, that boundary where they are equal. If I didn't have this or equal to here, then my line would be dashed, and any of those points would not end up working here. All right, so what I would do on the software then is, after I've got my line graphed and I've decided which way I want to graph that, I would select which section. So for my example, I would click B is the area that I want to have it shaded. Now I did this test point, and that's a good way, and 0, 0 is a great test point to use. You can just look at it, since we put it in slope intercept form, you're looking for all the y's that are less than this line. So sometimes what I do is I just come over and say, all right, here's the line, and I usually kind of pick that y-intercept, and I say, well, I want all the y's less than that. That would be down here. And there's my clue that, oh, you want all of this. So rather than doing a test point, you might just be able to eyeball it, all the y's less than that. If I wanted all the y's that were greater than, let's say that was, then I'd put my pencil here on the y-intercept, and I'd say want all the y's bigger. So that would mean I'd want to shade side A. Either way, whatever works for you. Now that example took a little bit of time. I wanted to kind of explain what we're actually finding here. Now let's just practice some of these problems with a little trickier inequality given to you. Looking at this example, I have the x on the left side and the y on the right side. I really wish that was the other way around. I want to put this into slope intercept form. Here I go. I'm going to subtract the 6y on both sides. Then I'm going to end up with 4x minus 6y is greater than or equal to 12. And then I'm going to move my 4x over there to the right. Remember, I'm trying to get this into slope intercept form. Now it's going to look like this, greater than or equal to. Since I want it to be mx plus b, I'm going to write my negative 4x first and then my positive 12. Last step is to divide by negative 6. Now I put this one in here because you have to remember from when we've dealt with inequalities in the past that anytime you multiply or divide by a negative number, which is what I'm doing here, I'm dividing by a negative 6, then this inequality has to flip directions. My greater than or equal to is now a less than or equal to. And then my negative 4 over negative 6 would reduce to 2/3 x, and 12 divided by negative 6 would be a negative 2. I'm going to come over here and graph that. My y-intercept is negative 2, and then I'm going to count my rise and run. So rise 2, run 3 would get me here. Rise another 2, run 3. Put as many of them in there as you want. Now I have to decide. Let's kind of go back to the software here. They want us to choose the type of boundary line. So what do you think? Should we make this line solid or should we make this line dashed? Remember, it has to do with the or equal to. Since it is an or equal to, I'd want to include all the points that land on the line. So I'm going to definitely click solid because that means or equal to. And then I have to pick 2 points that I know would land on my line. So my line, we've decided, is going to be solid, and it has to go through that. And I'm just going to pick a couple of those points that I came up with. My y-intercept was 0, negative 2. And the next point that I have there is 3, 0. And once I type that in, the software will graph it for you. And then it's going to automatically put an A and a B on opposite sides of that line, and you have to decide which one of those would work. So let's try both ways again. I'm going to do it with the test point. I'm going to plug in 0, 0 because that's super easy to type or to substitute in. I'm going to put a 0 in for x and 0 in for y and see if this particular point works, meaning I would want to shade that side that that's on. If 0, 0 does not work, then I'd want to shade on the other side of the line. If I put in a 0 for the y and a 0 for the x, I end up with 0 less than or equal to. This just becomes 0 minus 2. And this looks very similar to the last one, coincidence there. 0 is not less than or equal to negative 2, so 0, 0 does not work. I don't want to have 0, 0 shaded, which means I want to be shading on this side of the line. All of these points over here would work, and the points inside on side A would not work, so I'm going to select B. Let's try an example where we have 4 terms in the inequality, because you're going to have some of those thrown at you. Still, just got to work with getting it put into slope intercept form. I'm going to subtract 3. Now, what happens here is I have a like term to combine that with on this side over here. I'm going to be subtracting 3 from the 35. The negative is still there with the 4. Greater than 35 minus 3 is 32. And then I'm going to come back and I'm going to divide everything by negative 4 to isolate that. That's going to cross off, so I'm going to have a y. Remember that if I divide by a negative, I have to switch my inequality, so my greater than is now going to be a less than. And then the other thing that I'm going to do is I don't really like my number to come before my x. Remember, mx plus the b or minus the b. So I want the x term first, so I'm going to sneak this in front. Negative 8 divided by negative 4 is a positive 2x. And then the 32 divided by the negative 4 I'm going to put next, and that's going to be a negative 8. Let's go ahead and graph that, find some points. Looks like it's going to have a y-intercept of -8. And then my slope is, think of it as 2 over 1. So I'm going to rise 2, run 1, rise 2, run 1. Do that a few times. And then before I graph, we have to make this decision. Do you think our line should be solid or should it be dashed? This one is not an or equal to. We should be dashing that. It's going to look something like this. Whoa, that's not the prettiest, sorry. And I have to pick 2 ordered pairs that land on that boundary line. I'm going to put that y-intercept, that was at 0, -8. And then just pick another point. I'm going to pick my next one was at 1, -6, it looks like. Once you graph that, the software decides, okay, we'll call this side A and this side B. Which side should we shade? I'm going to use my test point, 0, 0. Put 0 in for y, put 0 in for x. So that becomes 0 less than, this just is 0 minus 8. And then you decide, is 0 less than -8? Nope. I do not want to be shading 0, 0 then, which means, once again, looks like I need to be shading side B. I would want to shade all of these parts, so I would select B. Now again, let's go back and look at, could have I done that without having to mess with this test point thing? Since it's a less than, I can kind of go to my y-intercept and say I want all the y's less than, that's underneath it. So I would graph under the line. I can maybe decide it from that rather than doing the test point. Last example. Let's do this one that has fractions because those are always scary for some reason, but they actually kind of come out nice on this lesson. Because they're scary, the very first thing I'm going to do is I'm going to get rid of that divide by 36. I'm going to undo divide by 36 by multiplying both sides times 36. So this divide by 36, multiply by 36 is going to undo each other, and all I have left is 6x plus 6y is greater than, and 1 times 36 is 36. That looks much more like what we've been working with slope intercept form. Let's get the y by itself. I'm going to subtract my 6x. 6y is greater than, and I like to put the x term first, so -6x and then the positive 36. Divide everything by 6. That is not a negative, so I don't have to worry about switching my inequality. Reduces to -1x, which the software really prefers you not put that 1 and just write -x. Let's go graph that thing. It has a y-intercept at 6. And then my slope is -1, which means down 1, right 1. Down 1, right 1. Down 1, right 1. All right, those are my points. Let's go back to the software and decide, what do you think? Solid or dashed? It is not an or equal to. We should be dashing this. And let's pick out a couple points. I like my y-intercept always to start with, so over 0, up 6. And then the point that was next to it is over 1, up 5. Once you do that, the software will graph it for us. And then we'll designate a side A and a side B. And we have to decide which side we'd want to shade on. All right, let's try doing this without doing the test point, and then we'll come back and do the test point. I want all the y's that are greater than this line. So when I look at this line, I want everything greater than that. So that means above it. That means I would want this side A, because that's like the y's that are greater than that y-intercept of 6. It's up here. All right, I'm thinking I would select A. Let's check it with a test point. I'm going to always use 0, 0. Let's see if 0, 0 works. If 0, 0 works, then I want to shade there. And if 0, 0 does not work, I'd want to shade on the other side. 0 greater than negative 0, doesn't really matter, it's still just going to be 0. Is 0 greater than 6? Nope. So 0, 0 does not work. I do not want to shade where 0, 0 is. I'd want to shade on the other side. So all of these ordered pairs on this side of the line, but not including the points on the line, because see how it's dashed? It doesn't include those. I'd want to shade side A. All right, that's all I've got for you. Hopefully that helps you out. Good luck.